The tabletop shake table setup can be used to demonstrate and investigate the effect of sinusoidal, vibrational, and seismic movements for different materials and scale models. When calibrated correctly, the shake table can simulate scale positional data of various acceleration curves in a very accurate manner. Begin by opening the Parallel Shake Table 2 folder and then selecting Simulink and Operation Files. Next, select the Simulink 2015B folder, since this is the latest version of Simulink that can be used with the Quark model that is uploaded on the computer. There are single table Simulink operation files available for use as well, but we are going to head over to the Parallel Configuration folder. From there, scroll down and open the setup file. Ensure that you open the file using MATLAB R2015B. You can right-click on the file and select Change Folder to open all the shake table files in the directory on the left. Run the setup file and enter the load of the structure that's placed on the table. If you'd like to view the limitations of each table, you can type Y. Here you can see the various limits for acceleration and position. Once setup is done, you can use the Calibrate program to calibrate both the tables at the same time. However, if you do not have two calibration switches, this is not possible, and you should instead calibrate each table individually using either LabVIEW or Simulink. For simulating sine waves, there are two programs, one for parallel operation and one for biaxial. Loading the XY or biaxial simulation brings up the following control structure. We can close the scopes for now and select the ones we would like to see later, before running the simulation. On the left here are the controls for the amplitude and frequency of each table, which is one for each axis. Alternatively, you can also produce two different sine waves at each end for a parallel configuration. You can view sub-control structures by double-clicking on a control block. Jumping back to the main control structure, you can modify adjustable parameters by double-clicking on the value box and either entering a new value or using the slider. On the right, you have various scopes which can be opened again by double-clicking on the box. These update in real time as the simulation runs and can also be viewed after. To run the simulation, you must first build the controller by going to Quark and then selecting Build. This may take a while. Once you see that the model has been downloaded to the target, you are ready to start the simulation. Going back into Simulink, you can open up the desired scopes that you would like to see. And then go to Simulation and select Connect to Target. However, it is more likely that parallel operation will be used over biaxial operation, so we'll see how to simulate that instead. If we go back into MATLAB, select the parallel sine model instead of the XY sine model. Again, you can always run the tables in parallel using the XY model, simply by orienting them in the same direction. However, you must control each table individually, which is not ideal. Again, we'll close the scopes for now. As you can see here, both tables are controlled by one set of control inputs, which can be modified in a similar manner to before. To build the controller, go to Quark and select Build. Once again, wait for MATLAB to compile the model. Going back into Simulink, open the desired scopes by double-clicking them. Then select Simulation and choose Connect to Target. Hit Run to start the simulation. To ensure accurate positioning, it is best to calibrate both tables to zero displacement before running, although for demonstration purposes this is not necessary. Opening MATLAB, there are two make files, one for generating a compound sine wave and one for generating an earthquake. In this case, the preloaded earthquakes are already commented out and available for use. If you would like to use your own earthquake files, they must first be copied into the working folder that MATLAB is using. So, if we take a look at the peer database that we previously downloaded, we can then select any .at2 file that we want to copy and put it into the working folder. In addition, you must change the X and Y file names to the new earthquake that you would like to simulate. Since it's being run in parallel, it would be the same file name for both X and Y. You may simply comment out the earthquakes that you do not want to simulate and add in any additional ones that you would like to model. You can also modify the maximum amplitude of the table. Everything else should be kept as is, after which you can run the program. And here you can see the scaled acceleration and position curves for each table. Next, open the XY earthquake Simulink model. Again, you can close all the scopes and open the relevant ones later when you are actually simulating the earthquake. Go to Quark and select Build, and wait for MATLAB to compile the model. Once done, go back into Simulink and select Simulation and Connect to Target. Once ready, you can select Run and either allow the earthquake to run to completion or you can stop it at any time using the stop controller button.